This paper is titled Building a BW Tree Takes More Than Just Buzzwords. It's a 2018 paper. BW tree, aka buzzword tree, is a log-free data structure that provides high throughput for transactional database workloads in Microsoft SQL Server's Hackathon engine. The BW tree avoids logs by appending delta record to tree nodes and using an indirection layer that allows it to atomically update physical pointers using compare and swap. This paper has two contributions. First, it is the missing guide for how to build a log-free BW tree. Second, despite proposed improvements, the BW tree still does not perform as well as other concurrent data structures that use logs. The workload used in this paper is YCSB micro benchmarks to mimic OLTP index workloads. Author used its default workloads, that is a read update mix of like 50-50%, read only workload, scan insert in the ratio of 95:5 with Zipfian distributions, which have skewed access patterns common to OLTP workloads. BW-tree and OpenBW-tree index is configured to enforce unique keys. OpenBW-tree uses a max inner node size of 64 entries and max leaf node size of 128 entries. There are two key contributions of this paper. First contribution is a complete design for how to build an in-memory BW tree. This paper presents several additional enhancements and optimizations that improve the index's performance. The culmination of this effort is open source version called the OpenBW tree. This paper shows that OpenBW tree outperforms original BW tree design by 1.1 to 2.5x for insert heavy workloads and 1.1 to 1.4x for read heavy workloads. Second contribution is to compare the OpenBW tree against four other state-of-the-art in-memory data structures. Skiplist, MassTree, which is hybrid of trie and B-tree data structure, a B plus tree with optimistic log coupling, and ART, which is adaptive radix tree with optimistic log coupling. Now let's give this paper a PS score. It's a nice and easy read, so it gets 9 out of 10 on readability. The total length of the paper is 16 pages and it's dense in certain parts, so it gets 8 out of 10. It'll be challenging to reproduce the results, so it gets 8 out of 10. Industry value is a bit questionable as it's very specific to implementation of BW tree, so it gets 8 out of 10. It's good to read about BW tree and there are some neat tricks and experiments presented in this paper. So on Learning Meter, I'll give it 9 out of 10. So the overall PS score is 8 out of 10.